Oh yeah. Hello everyone. Uh, this is the part two of the tutorial of Amplicon Metagenomics in Genius Prime software. So in the previous video, we did the pre-processing of the Amplicon data. Then we clustered the reads using de novo assembler, and then we set up the custom blast and we were running the blast, but it was taking some time. Hence, I decided to end the video there. So as you can see, NCBI Blast have some rate limits with the Genius browser. Hence, matching regions with annotations take time, plus it requires good internet speed too. So to get the blast results quickly, when we do the blast, so on this data we use the blast. We do the blast, right? We check this consensus and unused reads, and when we click on the blast, so instead of matching, uh, clicking on matching regions with annotation, we can click on just matching regions. So as you can see, already they have given a warning that it will be a slow one. So it will take, I guess, 3 to 4 to 5 hours, I guess, if we do this. You can click on matching regions and you can uh, and, uh, just set up the parameters like you can see on the screen, and you can just click on search, and then you will get the results like this. So yeah, so you can get the results like this, and then uh, now we will remove the duplicates, we'll download the hits, and we'll do the further steps now. So first we'll remove the duplicates. So we have to just select this folder in which we have the blast hits, and then we have to select all the blast results which we got there. Okay, and then we have to go to edit, then we have to go to find duplicates, and then uh, in the find we have to do documents with same name with search scope, current folder, and this is okay. Select the most modified, recently most modified duplicates. Yeah. So click on OK, then you will get the hits there. And at this stage, our blast hits are like only summaries, and we need to download the full sequences. So we have to select uh, all the sequences of the document table. So again, you have to select all the sequences of the document table, and then uh, you have to just do is download full sequences, and it will download the things. Okay, and to keep our database small and speed up the classification process, we will extract the only the regions of the blast hits which are relevant to our amplicon. Okay, so to do this, we have to select all the sequences. Again, we have to select all the sequences and click where's the annotations. You have to click the annotations tab, and under its type, select the last hit and click on it. Click in the table uh, like this. It will just get everything selected, and then we have to click extract. And here you can see select extraction of 45 annotations. Just click OK, and it will just make the things easier for you. So yeah, and so now we will create a database. So basically, we just have to uh, create the we just have to simply place the list file we just created now, this one, and we have to create a new folder in it uh, to make a database. So to do this, we have to select just any folder. and just click a new folder there, and we will give the folder name as SRR714008316S and database. Okay, now we have created this folder. Okay, now what we have to do is, as I said, we have to take this file into this. So just the easiest thing is just to drag and drop here. So as you can see, this thing, the extraction for the list which we extracted came under the new folder which we created. Now we have to rename the database entries. So like as I said in the last step, we will rename the extracted blast hits which we got and give the name of their source organism. So to do this, we have to select the database list like this, and we have to go to edit and then batch rename. And you just use the settings which I am doing. This is sequences and sequences. Okay. Name of the sequence. This we have to do as organisms, as we have to put. And others, other things are, I guess, okay in more options. I don't think so. We have to do anything. Yeah, I guess we are good to go and just click OK. And yeah, so we just confirm it and click OK, and it will make one blast hits. And then in the last, we have to classify the Amplicon data set. So we'll now use the Geneious sequence classify plugin to analyze our merged Amplicon data set using our newly created 16S database. So that we will be using the original list of merge reads, not the OTUs, like this ones we will use. And we have to, I guess, download the sequence classifier. So I will go to this tools, then plugins, and then I guess, yeah, this is the sequence classifier, classify sequences. We'll just install it. Yeah, okay. So it is installed. Click apply, click OK. Yeah. So now select the files of the process reads you created in the step one. So processed is this one. I will show you. This one is framed, merged, length 50 and 50 to 260. Yeah. So we have to select this file, and then we have to go to tools, then classify sequences, and first click on the database folder. Um, First click on the database folder and select your newly created folder, which is the Mm, okay, maybe it is not shown here, but is you have to select here Metagenomics, SSR, batch 120, and this one. Yeah. So select this one and click OK. Now, because the 16S amplicon sequences in the data set come from only the V4 regions of 16S, so they do not contain enough resolution to classify the species level. So we will use the taxonomy field on our database sequences to classify the amplicon reads to um, genera level based on the percentage pairwise identity with the database sequences. So to do this, set up the classifier with the settings shown like this, which now we will change. Now minimum overlap will be 100. Then So 0.2% result to classify database sequences. We have to, as I said, we have to put in taxonomy field. I guess semicolon mm, instead of we'll put 95%, here 90, and here 85. So these things which I'm doing, this is basically based on the tutorial. So you can do it according to your needs, your necessity. So you are free to change these things according to your needs. Then the create table is okay and everything is okay, I guess. And just click on OK. Uh, just check once. This is okay. This is okay. I'll just put the sensitivity to medium. And yeah, I guess everything is nice. And I'll just click OK. Uh, so when we'll click on OK, the classifier will run. And once completed, the result will be returned to a report document. So, I'll show. So yeah. So the report document comprises three tables labeled summary, um, classifications, and one is of the results, like this one. So summary table lists um, how many of your sequences were classified using your database according to the criteria. The number of unclassified sequences are also displayed in the list basically. And then in the classifications table, this table lists all of the sequences submitted for classification and provides the details of the match used to make the classification basically. So if you select any sequence in the classification table, and it will give you then like the details of everything you can see basically in the results table. So like this is have overlap identity of 95.45 where you will get its query identity, which taxonomy it was, and all the stuff. This one. So yeah. So I guess we have done everything in this. We can actually export this thing. Um, maybe if you want to export the classification table, then we have to export the table, then select the location where you want and just save it. And I guess it will put the documents under CSV format into your location, and you can uh, do other purposes like you can do data analysis also in that. You can do some machine learning projects also in that. You can basically just play along with all the things which you have did through it. So yeah, this is all about the tutorial which we did for the Amplicon metagenomics in the Genius Prime software. Uh, yeah, let me know how you all got this video. Thank you so much. Share it to the people who needs this. And yeah, thank you so much. Thank you for watching. See you next time. Bye bye.